What's up, folks? We're going to discuss the STL in C++. Stand by. This video is about to start. This is the Savage Scientist Ed right here, and I'm writing code in a police car. What's up, folks? This is the Savage Scientist Ed, and today we're going to talk about the Standard Template Library, or STL, on this 18th day C++ program. So while you're checking out these timestamps, don't forget to hit the like button and the subscribe button. So it's time for us to move into this STL content, starting with the introduction. So you might be wondering, why am I holding this book? Well, this is an old book from 2000, 1999, 2000, somewhere around there. That's basically the Bible for the Standard Template Library. And this is by Nikolai M. Justicius. And I can't say this guy's name, but Nikolai M. Justus. I'll just say Justus. Let's put that over here. One more thing before we go further into this video. I have this website listed to cplusreference.com. There you'll be able to find more information on the data structures, iterators, all the other good stuff in the STL. The same stuff that you would have in this book, but an updated version. So click the link in the description for more information on STL data structures. So now it's time for us to talk about templates. And in STL, the T stands for templates. So now, what is a template? Well, a template is a parameterized type or a way of representing our type as a parameter. And in Java, this is known as generics. And since we're doing C++, we're going to use templates. It's all the same thing. In any other language, it's the same concept. So we're going to start off creating our template using the template keyword. And then we're going to have our angle brackets right here, angle brackets. And we're going to have the type name keyword, followed by a T. Now you can use a N, a V, or R, whatever we're going to use, but we have T here because that's the standard whenever we doing this in C++. So here's an example of actually using our template. So we are using of type T. We're going to have a variable called X. And at runtime, X is going to get the type of whatever is on the other side of our equals. So right here, we have a quiz. Pause the video, figure this out, and we're going to come back. So hopefully you had enough time to figure this out. So what is X referring to? Well, in this example, T is a constant character array. This is a constant character array. And we would normally write that as and Twitter has 1, 2, 3, 4, 5, 6, 7. So that is what X referred to. So we could have came back and modified this code, and instead of having the word Twitter here, we would have 78. So in this example, what is T referring to? This is an integer. So X is an integer. I know this might be a little complicated, but play with it a little while. We're going to get into more examples of using this later. So you're going to start seeing this notation as we dig deeper into the STL. So in the STL, we also have our string library. That is identical to creating a character array, but we have access to many functions like size. We could call the size function, and that's going to tell us how many elements are in this string. Let's say this string is called S1. So we would just say S1 size, and that's going to tell us 1, 2, 3, 4, 5, 6, 7, 8. That's going to return the value 8. That is what the size function does. So you can't do that in character array. So this is powerful stuff here with our string class. So now let's move on to vector. Vector is kind of like an array powered by a Hellcat here. In comparison, a vector would make an array look like this. 797 horsepower. When you move from an array to a vector, you're going to have a lot of functionality. Like you could use some of the sorting algorithms on it. You could use push, pop from push in, push from the top, pop from the top. So it could act like a stack. You have, so you could still address elements in a vector the same way it would be done in an array. So we're going to talk about vectors later in this video. I want you to notice with our vector here. Our vector is called V1, and it's going to have some type. This type will be declared when we create our vector. So we're going to have more of that in this video, so stay tuned for it. So in this example, type could be int, bool, character, or even a class, some object. So vectors are powerful. That's all you need to know. And read that. If you want to know more, don't forget to check this out. A lot of information about vectors. Or click that link in the description below. So vectors, very powerful. So now let's talk about our map data structure. It creates a key value pair. And notice, we're using our templates again. It's gonna pair two types. So this could be int and character, or anything else. Int, character, character, and it's gonna create a key value pair. We're gonna talk about that in this video. So next, we're gonna talk about some of the STL algorithms. Very powerful stuff. Like our reverse algorithm. We're going to have our sorting algorithm that puts it in order. And we're going to have min and max. And in map, max and min is the same as ceiling and floor. So we're going to talk about that in this video. So it's time for us to start coding. So follow me along to Dev C++. We're going to start off by creating a new project. And we're going to name this one Day 18. And it's going to be a console application. And select our Day 18 folder. Save everything in there. And we're going to put our user namespace std line right here. So first we're going to use strings. To use string, we must include our header file for string. Include string. That's it. Let's create our first string. String S1 equals capital Swampland is Arctic City. And let's print it. And there's the results. Capital Swampland is Arctic City. Beautiful results. So let's go in and modify our string. So how many characters are in this string? So let's see. our character count, meaning how many characters are in here. We're going to go to s1.size. So it's important to start paying attention to the documentation on the classes and the methods that we are using as we continue to explore the STL. So looking at this screenshot, std scope resolution are 2: string. That is saying our string S1 string. That is actually where it comes from. It's part of the standard namespace, and it's a string. It's the same thing as saying int or character. So the size method returns right here a constant expression size type. That's just meaning that we're going to return an integer value. And that's the name of it, size. And that's basically it. We are using the size method. When you look at the official documentation on the C++ language, it could get a little confusing, all this other crap. But if you look and use the book, it's a little easier. And the examples are probably the best way to look at this stuff. So that's why I have an example. So in my example, we're using the size method on our S1 string. So let's continue. And now let's recompile it. It is showing the size of this character string as 39. So this is something good. So here's another great one. So now we got our size here. Let's print our string in reverse order. So let's put our algorithms to work. Algorithm, include algorithm. And this gives us access to the reverse function. So we could come right here on line 10, reverse it. And the first argument in reverse would be the beginning position. So we could say s1.begin, B-E-G-I-N. And our ending position would be s1.end. And this function will reverse the order of our string or whatever we have in our array. And here's the results. We can put our string on its own line too. Let's do that. So what I want to do is first I want to print our before and after on our string. So this is the before line. This is after. This is our assignment and declaration statement. And this is where we're going to print the string before we hit line 11. And this is the reversals on line 11 and on line 12. This is the results of our reversal. So this is what our string looked like after using our reversal algorithm. String reversals is a great way to test for palindromes or to piss people off in a live stream. So looking back here at line 11, we're using our STL reverse function. And once this function completes, we have just mutated our original object. In this case, it's S1. S1 changed and is not the same. So that's the reason why I wanted to show you on line 10, the before, and on line 12, after. The size remained the same. The contents of our string changed. So let's play with some vectors. First thing we're going to do, line 3, hit our include statement. Include vector. And it's still part of the standard template library, so this line 5, is still valid. We're going to remove all the code from our string experiment. So let's start here on line 10. We have our vector name. It's not a keyword, it's just the name vector, because vector is a class within the standard template library is just the name of our container. And here is our template. We're going to use integer, and we're creating a vector of ints, and it's going to be named v1. And to find the size of v1, type in v1.size. And let's print that information. We want to find out how many elements are in our vector. So size of v1 equals an integer value. So we could go to line 11 and take our v1.size, because that function returns an integer value. So we could put the results right into our cout statement. And let's make sure we include our brackets to make it so cout works, because we want to print the size value of v1. And we have an empty vector. We could resize our vector on the spot also. v1.resize. We're going to set it to the size 90. 90 elements in this vector. And that's how we resize a vector. It is very difficult to resize an array in the same way. We would have to copy the array. We would have to copy each element to a new array. So that's one of the advantages about using vectors, the resizing capabilities. So let's add some items to our vector. So one way we could do it is right here in the constructor, or right here on line 10, when we create it, we could just put our numbers here, 2, 34, and 91. So if we want to print all the values in our vector, we would have to do it the same way we would do an array. Using the for statement. So for int I equals 0, the next part is going to be the while part of it. While I is less than our v1.size, we're going to increment I. And now for the printing part, we're going to just remove this line. Now, we're going to copy this. We're going to copy and drop that on line 15. So even though we just copied this, we want to look at v1 at the position I. And we want to also print I. So v1 equals this, and we want to space after our value here at position equals I and in line. And here's the result of our vector. As you can see, only 3 elements are in the vector. At 0, we have our 2. So this is 0, 1, 2. And you see how those match up. At 2, we have our 91, 0, 1, 2. So to simplify our results, let's get rid of line 11 where we resized it to 90. So now that we got rid of that resize, our vector looks the way it's supposed to. So let's remove some items out of this vector. v1 dot push pop back, P-O-P underscore B-A-C-K. That's going to remove the 91. Now the 91 is gone. It stops at 34. So I know I said we wasn't going to talk about iterators, but in this example, we're going to put our 91 back into our vector v1 after calling the pop back on line 11. So there's a lot of ways we could have did this, like we could have just said pushback 91, but that'll be using the same. So that'll be something that we already covered. So let's take a look at how to do it with iterators. So first I'm about to copy line 12 because I want to show the size of our vector again after adding our 91 again. So right here, we're going to just put a line in here, COUT, that just so we could know whenever we review our code where it is insertion happened. Insert INSERT 91 using iterator. So we're going to use the insert method. All right, so first thing we have to do is create our iterator. So iterator is part of the vector class. So to access that, we would have to call it via a vector. So we're going to go into our vector of int, because that's what v1 is. It's an int vector. And you can see it right here. We could also bring this in so it could look similar. And we're going to use our scope resolution operator to access iterator. And we're going to name this v1 iter. And that's all we have to do. And now that we have our vector iterator created, we want to set our vector iterator to the beginning of our v1. So let's do that on line 15. v1, capital ITER. So now let's call our v1 insert. And first we're going to put our v1 begin. And we want to add 2 to the beginning because we want this position. So we have 0 or we have 1, 2, 3. So we're going to put it at 2. And it's going to be the value 91. And that is directly using this method. Iterator position. This is our value 91 right here. Constant value of whatever type we had. So let's see what happened when we run it. So after our insertion, our size, after inserting, our size changed to 3, and our 91 is at position 2, 0, 1, 2. So we were able to use an iterator to insert a value into our vector. So we could have got rid of all this line 15 and 16 and insert it into our vector using the bracket notation. But first we have to resize the vector. And we're going to set our new size to 3. And now we could go into v1, 2, and set that to 91. And now our 91 is back inserted. And I also want to demonstrate sorting. So as you can see, this is out of order. We have 3, 122, 334, and 91. Let's sort in descending order. We're going to add more items to our vector. Let's see, v1 pushback 1, the number 1, and we're going to do a couple more pushbacks. So we're going to do 21, 31, negative 198, and 12. And let's sort this thing now. So we're going to start off with STD, Standard Template Library, method or algorithm called STD Sort. S-O-R-T, that's our sort. And now we're going to start from V1, begin. That's going to return the beginning of our vector. And if we want to sort through some arbitrary values, we could have actually specified the numbers like from 7 to 300. So we would just use those constants if we want to sort within that range. So we're going from beginning to end of our vector. So we're going to go v1.end. That's going to return the end of our vector. And now let's print. And our vector has the size 8 now. And the lowest position is the negative 198. And then it's going into an ascending order starting with the 1. And it's going to stop at 334 because that's the largest member of our vector v1. So we discussed vector now. Now it's time to talk about maps. So to create a map, first we got to have our include statement. Include map. And the map is still part of the STD namespace, standard namespace, or the STL, however you look at it. And you really don't need string vector and algorithm. Well, we're going to probably use algorithm, but you really don't need string and vector at this point. But to keep track of the topics that we already covered, I'm going to just leave them in here. So let's get rid of line 8. And we're about to clear all the code that we already wrote. So put that bracket on its own line. And now let's create our plan of what we're going to do. We're going to create a map. A map is a key value pair. And we're going to create a class, the model inventory in the store. So let's create our class, the model the store. Class item. And we're going to give our item public access. And we could have used structure too. I mean, it probably would have been better to use a structure. So we already started. So let's use item here. So our item will have int. And this is going to be our availability. And we're going to have a character. Oh, we could have used string here too. But we already started with character array. So we're going to give this our description. DESC for description. And the last thing would be double price. So we have our item here. And now let's create our map. Start off with the map keyword. And now for our template part, it's going to be 2 parts in our template. The first part will be one class or one item type and a second item type. So the first one here is going to be, let's just say it's going to be an integer. And our second would be an item. And the name of our map would be store. All right, so let's create a few items for our store. So item 1 would be I1. And we could use, and to populate our item, we're going to use the bracket notation separated by commas like this. So the first thing, or the first comma separated item will be our availability. So let's say we're going to have 23 of these items, and the description would be, or really the name, LG B60. Piece of crap. And the price would be 0.16 cents. So we have one item for our store. And let's go up to line 12 and change our character array to a constant character array, because this is a constant and we don't want any problems in our code in the future. So let's create some more items. I'm gonna just copy line 19 5 times. So in this store, no one is buying V60s, no matter how cheap it is. So let's increase our quantity to 233. I can't even give these things away. Let's hit line 20 with item I2. We can have 2 Bonnevilles in stock. And let's set the price to $988.16. I don't know where these prices coming from. So our next item, I3, we're going to put 23 of these in stock. And we're going to name this, this is going to be some C++ books. And we're going to set the price to $32.88. All right, so let's do item I4 here. We're going to name this junk food. And let's set our junk food to $9.01, like the Memphis area code. And let's set our stock to 523 items. All right, the next one, we're going to name this hammer. And we're going to set the price to $1.12. And we're going to put 3 of these in our inventory. Let's change this I1 to I5. And let's move to item I6. We're going to put 1 of these in our inventory. And this is going to be 1 Hellcat. We're going to sell this for $2.16. You better act fast because it won't last. I just got word that LG stopped selling phones, so we are about to change the value of our V60 to negative $30.16. We are paying people to take this out of our inventory. So now we are about to insert our 6 items into our map into our map object called store. So there are multiple ways to do this. So the first way we could do this is use the insert method. So we'll call insert from our store. Like that, store.insert. And we're gonna, since this is a method, we're gonna use method notation just like this. And we're gonna use curly braces. And the first one will be our key or our index. So we're going to start with index 0, and we're going to insert item I1. So we just inserted our first item. So we could also insert items into our map using the square bracket notation. So we're going to insert into item 1 just like that. And we're going to use our equal sign, and we're going to set it equal to I2. So that's it. And the reason why this is working, this and this, is because our map takes an integer and an item. So that's our integer, and this is our integer. If we were to change this to character, we would be putting characters in our square brackets and in this first part of our insert function. So let's insert some more. Let's see, in 2 we're going to have I3. So on line 29, let's do store.insert. And we're going to do 3 here and I4. Close everything up. Take that. So insert. And we're going to put 4 here. I5. and STL insert and this would be 5 I6. Let's close everything up. All right, now that we have all the items in our store, or we have our inventory, this is how we could count how many items we have in our store, or how many unique items we have in our store. So we would just say store dot size. So the size method returns an integer value, so we could feed that directly into our cout statement and print our value directly to the screen. And we will be counting unique items in our store. So we're going to name this unique items. So we have our unique item count here. And now it's time to print all the items in our store. We're going to print this stuff. We're going to print our availability, description, and price. So let's start our post statement. And while I is less than, we'll just see 100. Because these values could be anything. So we don't count in a linear fashion. So we're going to say I plus plus. And pay attention to this video because I'm going to show you exactly why I used 100 here. All right, so now it's time for us to print our values, cout statement. Cout. We're going to print I because that's like the index. And we're going to put some space in between it. And, well, we could do a tab here. Tab there. And we're about to print store I. Use our dot operator to access this part. We are about to access our item. So dot is going to give us access to item. So dot item, and our item is going to end up, and we're going to print our availability first. So we would just say availability right here. Don't laugh at my spelling. Put a tab right there. All right, so now let's move to the next item we're going to do here. Store I dot price. And our tab here. And now store I description, DESC. Do we use DESC? DESC for description. And our inline statement is going to put this on its own line. And one more thing we could do is we could print out an index or make it look like a chart. I'm not trying to make a perfect chart here, so this probably won't line up straight. So let's create the index for our chart. This I in our chart is going to be our, let's just say, item number. And we're going to follow that by a tab. And we're going to have our availability and another tab. And we're going to have our price. And another tab. And description. And let's fix this. And let's go to line 35 and finish up our for statement with our I set to 0. And this is the while part. While I is less than 100, we're going to increment I. And I is basically making this line happen. So we're going to print the value I. And this is kind of like our key and our item. And everything in our item, like our availability, price, and description, comes from our item class. And here are the public members of our item class: our availability, which is an integer, and our description, that's a character array, and our price, that's value double. So I want you to pay attention to line 19 to 24. If you notice, we use curly braces to populate our items. So we could look at this method as a shorthand notation as to writing it like this, where we use the dot operator to access each of the member functions like the availability, description, and price to populate our items. So that explains why we use the curly braces on lines 19 through 24. Now, let's run our program. So this acts as our index or the header line in our chart. So let's highlight it. This corresponds with line 34, where we print our item number, our availability, our price, and our description. And you can see we have 233 LG V60s with a negative price. And everything lines up correctly. And we have our unique items 6. That means we have 6 different items. Let's set up a value to track how many items we have in our store. We're going to name this total items. And let's set it equal to 0. And when we get to this line, we're going to print our total item. And let's put a label here just to say what our total items are. Set in, put our brackets there. And now, this is how we're going to increment our total items. So we are looking at this line. So we will add this line every time. So we will say, so on line 39, we are about to set our total items. And we're going to use our plus equals. And what this is saying is we're going to add to our total items the new value of store I plus availability. So we're going to copy this line and drop it right here. So this line is going to update our total items with the availability of the current item. So if we were visiting item 1, is going to update our total by 233, and the next one is going to update it by 2. So let's see that in action. So you notice our unique items is 6. So we have 6 different items in our store. But our total items didn't print. And that's because of this. We tried to access an item that doesn't exist with key value 6. So what I'm showing you here is if we access a value that doesn't exist in our map, we would lose the ability to traverse our map using key values. And the only way to get back to the beginning of our map would be to use an iterator. So to fix this, the only thing we have to do is hit line 36 and change this 100 to 6, meaning while I is less than 6, we're going to print the value. We're going to run through this count. And we'll be able to see our count now. And there go our count. We have 785 items in our store. And the reason why we didn't get this line last time is because we accessed an item that's not in our store, or that is not in the inventory in our map class. So technically, this is the end of the video, but I want to provide you with more important ways of dealing with our maps and our iterators. So I'm about to show you the erase function in our map. And remember, when we're using our erase, we are erasing based on our key value, which is an integer in this example. So all our keys can map to this 0 on the insert and this 1, 2, 3, 4, and 5. So let's remove an item. And we're going to put it after we initialize our items to 0 on this line 33. So let's erase an item. So from our map object, called store in this example, we're about to call the erase function. And erase just basically removes the item based on its key. So this is going to be our key. And so we're going to remove item 3. And now let's run our program. So here's our results. Once we deleted our object, we broke the link, so we couldn't access any more objects in our store. So I'm going to show you how iterators work and why it's better to use iterators to move through our list instead of playing around with our index values. And also, we could use characters, objects, anything for our key value. So I would not advise using objects as our key, but it's possible in C++. So iterators provide a more universal solution to this problem. So let's go and create the iterator. So let's start right here before our erase. And let's create our iterator. So we're going to start off with map. That is the container. And our current map has this signature, an integer and an item. So we're about to call the iterator from our map class that's going to create the same style of map. So we're going to hit int and item. And we're going to use our scope resolution operator to access iterator at the class level. And if you go through the documentation on map, you would see that iterator is a method or a member of our map class. We're going to give this iterator a name and call it iter. And we're going to set it to the beginning of our store object. So that means it's going to point to our first insert right here at position 0, line 26 with key value 0. So let's set it up. Store.begin. And that's how we create our beginning and use the iterator so we could print out all the items in our store or inventory, and we're going to compare the results. So with our iterator, let's create it on line 34. We're going to use a while loop this time. And we're going to say while iter is not equal to store.end, we're going to process some actions. And I want you to pay attention to iter. Iter is a copy of our map object. So right here, this is what iter is. It's one of these pair structures or tuples. It contains an integer value and an item. That's all iter is. And it's a pointer. So that means we can't use the dot operator when referring to the first and second argument in our iterator. We're going to have to use the arrow operator. So now let's print the contents of our map. Start off with cout, iter, first. So first means the first item or the first object in our map. Second is the second item. So we can look at this in this form. So int is first, item is second. And when we print item, you notice we're going to start using our dot operator, and it's going to act the same way as when we used it on the store object. So it's only the first and second that we're going to use our arrow operator. So when we call first, we are just returning an integer value. So iter first, pointing to that first object. So that's all we need, because we printing in the same order that we have in our for statement when we used our array-like notation. We printed the I value, so we are printing something like our I value right here. But we printed our index or key. So next, we're going to go into store. So next, we're going to put some space here in the tab. And the second thing we're about to print is iter second. And now we're about to access our item class. And this is the item class. So we want to access our availability, our description, and our price. And we want to do it in the same order we did it using the for loop, or whenever we didn't use an iterator. So we're going to call second dot, because now we actually referring to our item or our object. So we're going to call second dot availability. And we're going to put a tab here. And we're about to call iter second. And remember, when we say second, we are just talking about this item, first and second. I think I'm done repeating myself on that. I just want to make sure I'm not skipping it. So we're going to call second price. And let's move to another line. And we're going to call iter second description. And we're going to force this on its own line. All this is going to print on one line, similar to how it looks here. And we could have put this on another line too, so it could be shortened. And if we leave our while statement in this order, we will have an infinite loop and it will not work. So now we have to move our iterator with each loop. So to move our iterator is similar to how we move our I value to move to the next item. So to move the iterator, we just say iter plus plus. And to understand how all this works, I suggest going back into the documentation on iterators for our map class. And it will provide you with more than enough information. So this is what it looks like. And I'm missing a tab, so let's put a tab in here so we can get this to look exactly like that. So right here, we should have had another tab. And I also want to put a line here so we could see the difference. Not using iterator. Notice, when we used our iterator, we got our Hellcat and our Hummer. But when we used the array notation, that allowed us to point to the element at index 3, which was already previously removed. That blew up our program, so we couldn't access the remaining items in our map. But notice highlighted in this green, when we used our iterator, we were able to skip 3 and continue looping through the rest of our map. So that's the reason why I stressed iterators. And I'm sorry we had to go back to iterators for this video, but that is why this is so important. So this is the Savage Scientist Ed here with another video on C++. And this concludes day 18. So till I make my next video, peace out.